G'day, it's Mr. Bennett here. Today we're going to be looking at concept of motion, and so we've got a PowerPoint I'd like to go through with you, so we'll just start that. We'll be looking at acceleration today, but we'll certainly go through the speed, position, velocity. Now, I'm going to start off with the concept of relative motion. Now, use an example, is if you fire a bullet goes at about 1,000 metres per second. If you were travelling in a plane, relative to that bullet, if you were travelling at the same speed as that bullet, it would be possible to open the window up and put your hand out and grab the bullet, wouldn't it? Right? Because you'd be travelling at the same speed. So relative to the plane, the bullet would be stationary. So it'd be easy to catch, wouldn't it? So the idea, when we start talking about relativity, you might have heard of a guy called Einstein's theory of relativity. This is what we're relating to. Right? So everything appears to be stationary. Now you might think you're sitting at home right now in front of your computer, and you think you're stationary. Well, you're actually moving at about 30 kilometres a second. Right? So in terms of the Earth is spinning, we know it takes a whole day for the Earth to rotate. There, we know that the Moon goes around the Earth every 28 days. And we know it takes 365 days for the Earth to go around the Sun. So in terms of relative speeds, right, it's quite crazy to think that we're actually travelling at 30 kilometres a second, right? But we are. And technically we could be talking about, a bird. A bird, let's say, is in a tree. A bird sees a worm, nice juicy worm on the ground, right? Flies from the tree to get the worm, and say that the bird takes a second to get to the worm. Right? We know that the bird doesn't miss the worm by 30 kilometres because that was how far it would travel in that time. The reason why that doesn't work is because the bird is already moving at 30 kilometres relative to the thing. So it's in the same frame of reference. Alright, so you get the idea of relativity. So if we start talking about objects that move really fast, well, we've got obviously racing cars. They move at about 500 kilometres an hour up to, it's probably not that fast, 300 kilometres an hour relative to the track. All right. When we start looking at the space shuttle, it moves at about 8 kilometres per second relative to the Earth below. All right. So it's like the space shuttle, when it's in orbit, only takes about 90 minutes to go around the Earth. And we could talk about our satellites, moving around as well. So racing cars, Indy cars, about 300 kilometres per hour relative to the track. So it's relative to a frame of reference, which is really important when we start talking about that. Alright, so the Earth's surface moving about 100,000 kilometres an hour relative to the Sun. Alright, now you don't have to remember this, but just get the concept of relativity. Alright, so you say you've got a hungry mosquito, alright, sees you lying in a hammock, and there's a nice breeze at about 3 metres per second. So how fast and in what direction should the mosquito fly in order to hover above you for lunch? Well, obviously it needs to fly into the breeze, doesn't it? And it needs to fly at the speed of what the breeze is going at. Right? So you get the idea of the relative motion of things. So how can you tell if an object's moving? Well, you need to be looking at the frame of reference. So when we start talking at Earth, we'll just assume everything is in our frame of reference. So if it's stationary sitting on the table, then we'd say it's not moving. All right. So we have to put things into our frame of reference. All right. Can you calculate the speed of an object by dividing the distance by the time covered? You certainly can. All right. So that's how the first thing, we've already looked at that in the previous video. So the speed is the distance travelled over the time taken. And remember, that's not a vector quantity, it's a scalar quantity. So the units that we'd be using for speed are things like miles per hour, but we don't really use that in Australia. We've got kilometres per hour, you've got centimetres per day, light years per century. You could use any unit as long as you've got a measurement of distance and you've got a time measurement for that. So we know cheetahs obviously can run really fast, they're the fastest animals. They can actually achieve speeds of about 100 plus kilometres per hour. Okay? So we primarily use the units of meters per second for speed. Now you don't have to always use that if you've got all your other units in other particular units, but we generally will bring things back to SI units, which is meters per second. So if a cheetah covers 50 meters in 2 seconds, then the speed the cheetah's moving at would be 50 divided by 2. Right, so here's a table just showing you the relative speeds. Now, the one that we're probably more interested in going kilometres per hour to metres per second. And remember I said what you've got to do there is divide that by 3.6. Right, so if you divide the kilometres per hour by 3.6, that will get you to your metres per second. So these are the different speeds, the different variables that you might see in everyday life. I mean, if you're into cricket, you know that they bowl at about 140 kilometres per hour. So that's pretty quick. It's up about that sort of speed. Instantaneous speed. All right, so cars don't always travel at the same speed. So in your car, you have a thing called a speedometer, and that measures the instantaneous speed. All right, so and you've also got this thing down the bottom here, which is called an odometer, which works out how far you travel. All right, so the average speed, right, is really the distance that you travel over the time it takes, and that's what we generally work out. If I said to you that we were travelling 240 kilometres in 4 hours, well, we then know your average speed was 6 kilometres per hour. If you got to Adelaide, and it takes, let's say it takes it's 100 kilometres, and you only took half an hour to get there, and you tell your parents that you're not speeding, they'll be not believing you, will they? So, I mean, nowadays you'll see, if you see those point-to-point radars, what they do with trucks is they take a photograph of the truck and the time, and then they have another point where the truck will go through, and they know if the truck gets there before a certain time, the truck's actually been speeding. Right, so it's looking at their average speed over a period of time. Alright, so speed is often different from instantaneous speed. Alright, so whether we're talking about average speed or instantaneous speed, we're still talking about rates at which your distance is travelled. Alright, so remember, speed is not a vector quantity. Alright, so the total distance travelled equals the average speed times by the time it takes. So if you were travelling at 80 kilometres per hour on a 4-hour trip, you'd cover roughly 320 kilometres. Alright, get the idea? So you can change those formulas around. So if a cheetah maintains a constant speed of 25 metres per second, covers 25 metres every second, in other words, how far will it travel in 10 seconds? Well, you could times that by 10, so it'd be 250 metres. And then if you wanted to work out a minute, you'd have to convert the minute to seconds, so it'd be 60. So you'd times the 25 by 60. Get the idea? Alright, so we'll just keep flicking through that. Alright, so there's another question for you. So a car, if at the trip you had 35 kilometres on your Odo, remember that's the distance that you travel, and it takes you half an hour to get somewhere. Well, the average speed is the total distance travelled over the time, so that would be 70 kilometres per hour is the speed that you're travelling at. So how can you calculate your speed? Well, remember we go back to that, well, it was the distance that you travel over the time that it takes. It's your average speed. Now, when we start talking about velocity and speed can be the same thing, but quite often they're not. So speed is basically how fast you're moving. Velocity is how fast you're moving in a particular direction. That's really important that we get the idea there. So in physics, velocity is a speed is given direction. So you must give a direction with that. Right? So you can either say left, right, north, south. Right? That's really important there. So a quantity such as velocity, it specifies direction as well. Right? So we call that the magnitude. So the speed is the magnitude, and the vector makes it a vector quantity. So speed is scalar. We know that velocity and force, even acceleration, are all vector quantities, right? Because the direction is really important. So constant velocity means you're travelling at the same speed. Right? Constant velocity means both the speed and the direction have to be in the same, don't change. All right? Does that make sense? So if we were looking at an example where something isn't travelling in the same direction, well, we can't say the velocity is constant. So either the speed or the direction or both have to be unchanged. So constant speed and constant velocity are not necessarily the same. Right? A body may move at a constant speed along a curved path, but if it changes its direction, then the velocity is changing. So here's an example of a car going around a track. Right? So we know it might be going at, say, 60 kilometres per hour. So its speed is constant. Right? But because it's always changing its direction to keep going around that circle, we will say the velocity is changing always. Okay? So the speedometer of the car moving northward at 60 kilometres per hour, if it passes another car travelling southward at 60 kilometres per hour, do both cars have the same speed? Do they have the same velocity? Well, yes, they do have the same speed, but one is going north, one's going south, so they have different velocities, don't they? Okay, so both the speed's the same, but the velocity is in opposite directions. So it's really important. So the question is, how is velocity different from speed? Have a think about it. I think it's a pretty easy thing. We've just been through that. All right, so how is velocity different from speed? Velocity has to have a direction associated with it. All right, so when we start, and we'll just leave the video there. All right, we'll be talking about acceleration fairly soon. All right, so acceleration we'll be talking about this, a change in velocity. I've got some questions that I'll have, if you look on your sheet, that you'll need to have a go at doing. I will go through in another video. I'll go through some examples of how you set this work out in terms of velocity and speed, and we'll also introduce you some other formulas. So when you have changing speeds and have changing, we have initial speed, maybe it's stationary, and then you might have a final speed or final velocity. So we'll be looking at some examples with that. So I'll talk to you in class. So have a look at those questions that I've left for you.